This one here, it asks us to linear regression. They're looking for patterns in the behavior of the data, whether or not it forms a straight line. You can deal with predictability as one gets larger, the other gets smaller, or as one increases, one decreases. In this case, give us a set of data points here, and they want us to plot the points, make a scatter diagram, so there's your scatter diagram there. Okay. And can we see a pattern in the data? Yeah, it forms somewhat of approximate linear relation here. And then he asks us to draw a trend line. A trend line is basically an estimate model of the data. We can use that to predict in the past and in the future of the data. Then he asks us to find what y coordinate goes with the x coordinate of 10. So we see when 10 is here, the y coordinate goes with it. The y coordinate goes with it is 8. Okay, then they find the x coordinate that goes with the y coordinate 8. So when the y coordinate is there, the x coordinate that pairs up with it here is 10. Okay, the y-intercept is where it crosses the y-axis. In this case here, we look at the graph when x is 0, y is 18. Then you want to know about the x-intercept, where it crosses the x-axis. So when x is 18, y is 0. And that's the end of that one. And this one here, they ask you to make a model, plot the data. In this case, T0 represents 1970, and T10 represents, and T of 10 represents 1980, and so on. Okay. So when you plot the data here, first thing you want to do, make sure you get your data points right. Don't try to do it all in your head. Go ahead and write it down. So when you plot the points, this describes the data here. You notice these are spaced out by tens. So these are spaced out by tens. Then they ask, draw a line that describes it, and this is your trend line through the data that best describes it. Okay. In 2010, so that would be how many years? From so 10, 20, 30, about 40 years. About 40 years. I have about 55. And they have 56 here. Okay. 20% of the degrees. What year would that be? Like about 13 years after 1983. And that's all there is for that one. So they go through the same things here. They ask you to draw a trend line. Find the intercepts. We've done that before. And you go back and forth here. Predict when the bump would be 4 bumps. So you look at the chart. 4 bumps will be in 8 years after 2000, 2008. What is the t-intercept? Where it crosses the x-axis here. Well, comes in about 10, looks like. Yeah, 10, 0. According to this, it'll be zero. The zero bumping will occur in 2010, and we have a model breakdown because it's not possible to have no bumping on the airline. It's always going to happen. this particular problem here, uh, estimate the t-intercept. That's going to be the temperature here. All right. So we look for when the other one crosses 0. Notice these are all zeros here. So we look for where the sign change is going to be at. And it looks like the sign changes between -5 and 5. And the coordinate that would match up with that is going to be probably 13. That's the closest one. Then he wants you to know, find the w-intercept. Notice these are all, the first coordinates are 0. So we're going to look to where it changes sign again. At -4 and 6, so there's a 0 somewhere in between there, -4 and 6. And somewhere in between here, between -12 and 21. And the only one that could be is a -16, so that's how they do that one there. And this one here has to find a model. So you've seen some examples already in the past. And they give the years here. The years since 2003 and 8. Okay. And they give you here the restatements. And so from here, the strategy is going to be find the slope, find the y-intercept, and then once we have the slope and the y-intercept, we can use the slope-intercept form of a linear equation to get an equation. So we use a slope formula to find the slope. Now we can plug in a point here, plug in a point to find our y-intercept. So we found our y-intercept. Okay, a b. So now that we know the slope and we know the y-intercept, we can get an equation. Now you can verify it using a TI-84 or a graphing calculator. Let's do the graph. Now the interesting thing about these models is that the more points you have, the stronger your model is going to be. Okay. And 6 is done this way, 7 is done this way. Consider the scattergram of data in the graph in the model. Sketch the graph of the model that describes the data. So what you can do here, what you can do is like before, get 2 points, find the slope, find the y-intercept, and then get an equation for the data, and then graph it. Same thing here. Same thing here. See, these models can be used to predict in the future. But keep this in mind. The strength of the model is in the number of points you use to create the model. If you only use 2 points, it'll be an okay model. But if you use 10,000 points to create the model, it'll be a much stronger model. The predictions will be much clearer and much more exact.